Hey guys, we're back at it again. It's May 31st. Um, it's 1:30 p.m. I just wanted to make sure that I didn't skip a day. I I did it yesterday. Yeah, I did do it yesterday. Yep. Um,
So lads, I did it again. Literally 8 hours, 9 hours after my last video. I woke up this morning and I was like, fuck, I really want to understand what else to try to understand this today.
yeah, that was yesterday. Um, um, I think that was yesterday, right? That has to be yesterday.
No, we will do it now. I understand the logic, but I have to code down, right? I fucking forgot what the solution was already. That I didn't remember it. Anyways. Um,
Was that yesterday? That was yesterday, right? That was yesterday. Yeah, that was yesterday. Yeah, okay, anyways. I'm tripping myself out. So today marks day 60. Proud of myself. Actually kept it going for 60 days. Yeah, so back at it again. Today is my sister's birthday party. So happy birthday's in the shot. And then let's do it now. You are given an n times n integer matrix board where the cells are labeled 1 to n squared. What the fuck is this? What's that?
Phụng thật là con xe hơi làm thằng nhậu.
이마, JB가 나. 네, 좋아.
That'll be fun.
Oh yeah. From the bottom left of the board. Yeah. Okay. You start on square one of the board and each move starting from square current do the following. Choose the destination square next with the label in the range current plus one, current plus one.
They pass right there.
Yeah, you can answer it.
Hả?
Oh yeah, oh yeah, oh yeah.
Oh, you're so fake. What yeah, funny than that.
N is the row. So I'm going one row up, right? What? Okay, if next has a snake or a ladder, you must move to the destination of that snake or ladder. Otherwise, you move to next. The game ends when you reach the square n squared, which is there. Ah, okay. Okay, I see. A board square on row R and column C has a sneaker ladder if board RC is not equals to -1. So these are all -1s. Okay. Okay, I have to understand what this means. So this is a 2 by 2 matrix. So negative, so in this case, right? In this case, it would be a square of 1, 2, 3, 4, right? So we starting from the bottom left, and then you move right 1 and 2. So this would be 1, 2, 3, and 4. So on the second square, you follow the ladder to square. No ladder, and this one will go to 4. Is that what it means? Ah, okay, so this would be the top row. I see. I see. Okay. This is pretty interesting. So in case one, let me understand the thing first. So this is row one, right? This is row two, boom. This is row three, boom. And then this is row four. So -1, and then 14 will go to 35. Yep. Boom, boom. And then this will come to here. So your snake back. And then row five, which has nothing. And then row six, I assume the second index, like the first index one will be 15, right? Okay. Okay, I understand now. Okay, all right. So what am I returning? Return the least number of dice rolls required to reach square n squared. If it is not possible to reach a square, return -1. Okay, all right. That's pretty interesting. So we start at 1. So we have in current equals to 1, right? That's where you start. And then while current is not equals to 36, right? uh the board n equals the board dot length. Board dot size. Right. N equals the board dot size is not equals to n times n. And then also have to initialize another variable called uh count, right? Row count, right? And then for each iteration of this, your next will be uh so in current will plus or equals to no well equals to current plus one. It's gonna be equals to something within this range. And within this range, I want to find the biggest one, right? Okay, so how to move? How should I be moving here? Mm. Um, I can put the whole thing into a map, which makes it easier, maybe. Um, the largest the map will be is 400, which doesn't seem that bad, to be honest. Okay, so if I were to do this, right, I might be doing something like this. So an ordered map, right, and then I'll have int, and then the result will also be int, right? Let's not use map. Let's use let's just map whatever. Okay, and then for uh row and board, and for uh cell in row, right? Oh, but it's gonna be in the snake style, right? So every second row, I will have to bool reverse equals to false first, right? If reverse is true, and if it's not true, then what should I do? If it's not true, then map, um, I should also have an int, right? Int, cur equals to 1. Map cur will be equals to cell, right? Uh, no, I shouldn't do this. So if reverse, right? If reverse is true, then what I should do is for um int for these are the constants. And then here I'm building the map. If it's reverse, then int I will be equals to n minus 1, right? Goes to n minus 1. And then I is bigger than -1, bigger or equals to 0, right? I minus minus. Because I'm reversing. And what I want to do there is map current will be equals to what? Map current will be equals to um row let me get I, right? And if it's not reverse, then it's simply for n I equals 0, I is smaller than n plus I. Map current will be equals to row I, right? I start from n minus 1 and I end at 0. I start at 0 and I finish at n minus 1. Yep. So I'm doing it in reverse. And I do that for every row. That's plus plus card, right? If it's reverse, then here I have to reverse again, right? So for every single row, which should start at So it should start at false, which is here. 0, 1, 2, for this map 1 will be equals to row 0, and then current will increase, and then map 2 will be equals to row 1, and then current will increase, then increase, 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 and then it increases until here, right? The map current will be equals to row, and then map current will be here. Current will be at 7. The for loop will finish, and then reverse will equals to true. And then for the next row, uh, reverse is true, so I'm starting at the end of the row, and then I will be equals to n minus 1, and then 7, 8, 9, 10, 11, 12. Yep, okay, I think it makes sense. Okay. And then now I have row count. And then while current, and then let's set current back to 1. And then while current is not equals to n minus n times n times n, and then current will be equals to the max of could be the max. So either it can do this, or it can do map current. No, I should just write a for loop for int I equals to current plus 1, plus how much? 6? No. Map I is bigger than next, then next will equals to map I, right? While current is not, current plus I, so it's the next one, current plus 1, 2, 3, 4, 5, 6. So it should be plus 7 should be the end. Um, No. It's bigger than current, right? If the destination of that thing is bigger than current, then if map I is bigger than current, then current will be equals to map I. Okay, so this is plus plus row count, right? And then how do I form this loop though? How do I form this loop? Like for example, if I'm at here, I want to check if the next 6 has anything bigger than this, right? If I, if I check here, there's nothing bigger than it is plus 1. If I check next, there's nothing bigger than it is plus 1. No, if there's nothing bigger than I just plus 6. 1, 2, 3, 4, 5, 6, right? I just plus 6. Okay. So for current, so I think that's fine, right? So next will be like plus 1, right? It will be plus 1. But if there is anything that is bigger than plus 1, if map I is bigger than next and map I is bigger than current, because there could be a point where next is 1, right? But then
Oh, it's a bit here. Oh, chăng hả? Đúng khi nào? Đúng chăng. Có lúc gì xin tôi mà.
Yeah, my grandma was leaving, so I had to say bye. Okay, back at it. Okay, so the next biggest move will be actually +6, right? Will be actually +6. And then, so I want to check within those six if there's anyone that is bigger than 6, right? Okay, now I'm at 15. I'm checking 1, 2, 3, 4, 5, 6, right? I'm checking the next six, but then I do found one that is bigger than 6, which is 13. However, it's not bigger than what I'm currently on. So what it has to be is it has to be bigger than 6, and it also has to be bigger than current. Then I'll make the jump, right? Then I will make the jump. And then what I want to do here is current plus equals next. That'll be one row, right? And then what's the edge case? The edge case is when I'm like around here, right? So if I'm at 34, if current is at 34, um, then this will be an error, right? Because it's accessing memory that is not allocated. So what I want to do is I want to do so this is actually not 6. This is actually this, right? So this will be minimum of current maximum it can go is 6. No, no, no. What should this be? What should this be? Wait. Okay, so this range, it has to be accessible, right? It for sure has to be accessible. The upper bound is 36. So I have to make sure current plus 7 will be within range. There you go.
Hold.
Oh, 你終於你唔好 fall into the birthday makeup syndrome, 好唔好? You know? It's gotta be just regular is pretty. Okay, right. This is a hint. This is definitely a hint. So the range will be current plus one and minimum current plus six or n squared. Right? Minimum is current plus one. And maximum will be the minimum of current plus six and n times n. So it's really current plus seven, right? Yeah, I think that makes sense. N plus n times n. Plus one, I believe. Because let's say you're at 34, right? And then you will loop between current plus seven and the minimum of current plus seven, which is 41 and 37. So you will stop at 36, right? And then next will be perhaps this current plus one and this. Right. The maximum you can go is six, but once it's at 36, you can't go anymore. Next would be what exactly? And then here I would return roll count. Next, I think everything is in place except for the next. I just have to find the right next here. Um, what happens if I put six here? Like that, maybe? Because because the next maximum it will be the minimum of six or the distance between so this is the distance between us I still have to go, right? And if this is super big, then it'll just default to 6. But if this is smaller than 6, then I'll go with that distance, right? If it's smaller than 6, like if I'm at 25, right? It will be the minimum of 6 of 36 minus right, sorry, here. 36 minus 30, then it'll be 6 at 6, then I'll just have uh right? Yeah, I think it makes sense. Okay. Okay. Let's try it. Please don't give me any errors. Okay, so it does work, but let's see here. I have one more. Why is that? Um, let's see. So I have the board here. Roll count is 0, while current is not equals to 36. Um, current is not equals to 36. The next would be minimum of 6 and 35, so it will be 6, right? And then for I equals to 1, 2, 3, a minimum of current plus 7, which is 8, and 37, so it will be I smaller than 8. So I'll go, if map 2 will be 15, right? So it will be 15, and map I is larger than current, which is 15 bigger than at 1. The next will be 15. Oh, it's not plus, which makes this much easier, right? Maybe that will fix it. Okay, everyone. Anyways, but I did find a flaw here. So because map I is 15, right? Map at 2 is 15. 15 is bigger than 6 and is also bigger than 1. So next will be 15 minus 1, which is 14, and then 1 plus 15 will be 1 plus 14 will be equals to 15, and then plus 1. So roll count will be equals to 1. Because I'm gonna scan these ones as well, right? 2, 3, 4, 5, 6, 7. It'll stop at 7 because I the range is smaller than 8. Um, so it'll stop at 7. Row combo plus 1. I'm at 15. Cool. The next will be 6 or 36 minus 15, 21. So it'll be 6. This will be 16 to this will start at 16. And then it'll stop at 15 plus 7, which is 23, right? 16 to 23. 1, 2, 3, 4, 5, 6. Okay, cool. That's right. And then if map I is bigger than next, so it will be, so let's see, 1, 2, 3, 4, 5, 6. Um, there's nothing bigger, right? This goes back, which is smaller than 15, so that wouldn't work. Um, so I'm just gonna plus 6 here, right? Which is 21. And then roll equals to 2. And then 1, 2, 3, 4, 5, 6. Roll equals to 3. 1, 2, 3, 4, 5, 6. Roll equals to 4. 1, 2, 3. Roll equals to 5. Yeah, that's right. The fuck? Oh, so it's 1, 2, 3, 4. Oh, oh, what the fuck? Okay, that makes it so much harder. I see. Okay, that makes it so much harder. It's not just okay. How the fuck do I optimize that? That becomes Dijkstra's, maybe? So it's the shortest path question, right? Yeah, it becomes a Dijkstra's question. It becomes the shortest path. Okay, 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 okay. Okay. Yeah, 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 yeah. Okay, I can do this. I can do this. All right, I understood the question wrong. Um, all right, let's go to some homework that I did. That will give me some thoughts. Now, what shortest path here? What is the shortest path algorithm? This has to be a shortest path question, right? Uh, so I'm looking at this in the starting source code. Shortest path, shortest here. I've done something like this before on LeetCode. Let's look. Let's see, shortest path. Oh, literally. Yeah. Back. Have I not done any shortest path questions? Yeah, I've done it. Okay, no. Takes for all the notes if it is impossible. Um, okay, so I have to create this list, right? I have to, okay, fuck this. What should the map of a vector? It's gonna be, what is it gonna be? How is it gonna be? What is it gonna be? I don't really know how to do this. Minimum rolls one is 0. Yeah, I'm thinking using a Dijkstra's.
来解那个离扣的问题啊。离扣的问题今天是第1631题，所谓的 pass with minimal effort。那这个当然是跟 们今天主要是来解答
What the fuck? All right, let's understand this. Let's understand this, right? Hmm. So this is initializing a vector minerals of size 37, and they're all initialized with -1 within. And then I'm initializing the Q, and then the minerals, second element of minerals will be 0, and then Q push 1. Why? Okay, sure. Not MT. We pop the front square of it. For each outcome after rolling a die, we use the T to store the move. We then find the row and column for our position using rows and column, which converts our location to 0 base index and computes then from bottom to left respectively. So this is a current, right? Okay, this is making sure the I does not overflow n times n. All right, and t equals x plus I. That is the next, right? Equals to t minus 1 divided by n Mm, mm, why is that? Let's say T is fucking 5, right? Where's on the first row? Then T equals to 5, T minus 1 equals to 4, 4 divided by n equals to 0. 4 divided by 6 equals to 0. Well, let's say if I'm on 34, then it'll be 33 divided by n will be 5. 0, 1, 2, 3, 4, 5. Okay, sure. Why do I want that? Okay, sure. Whatever. And the int v equals to 4. If it's an even row, if it's an odd row, then n minus 1 minus column. And if it's an even row, then it's just column. Is that what it means? Yep. If it's bigger than 0, then it'll be v, else it's just t. If y equals n times n, then I just return minimum rows x is 1. If it's not, what the fuck? What the fuck, sir? So minimum rows I equals to the minimum amount of rows that is needed to get to I, the I square, right? And then current is the front, and then I'm popping it, and then for int I equals to 1, I is smaller equals to 6, and x plus I in current, sorry, I is 6. Is smaller equals to 36. Fair. P equals to x plus I. Just testing the next one. And then row is t minus 1 divided by n. Column is t minus 1 modular. So let's say I'm here, right? Then t minus 1, which is 3 divided by n. What if it's 7? Well, t equals 7, right? Because I'm saying right? I will be here. And row will be 7 minus 1 divided by 6 will be 1. 1, 1, 1, 1, 1, 2, 0. And then I'm looking at V, n minus 1 minus row. So I'm looking at this row, right? And then if the row is even, such as 0, so these ones are the even rows, right? Yep. Because the last row will always be the n minus 1 row. The n minus 1 row will always be the first row. Will always be the straight row. Mình 1做一個0 1 2 3 4 Oh, that's why you need the row and column. And if it's not, then it's just column, simply column, right? T minus 1 lowkey, which is 5. Waiting. Y will be equals to V if V is bigger than 0. Y equals to N times N. Minimum rows of 15. I've never done it yet. I'll then have Y in the queue. And then I'll start at 15. And then I'm checking. It's 17. What? So it doesn't take into effect that the snake can take you back, can take you forward. That was quite interesting. Okay, so if I go back to the code that I had before, right? So if I just have to take out one particular condition, maybe I have it. Right, oops. If map I is bigger than next, And there is a time when it's impossible to what? Next. So here I should be at 15. Na, 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 na. Mm, 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 mm. This is the part that I don't get because it's taking it back, you know? So I'll just take it whenever it's there. I, okay, there's something wrong there. No. Okay, I fucked it. Okay, never mind. Da, na, 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 na. Da, na, 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 na. Na, 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 na. No, 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 no. I get it. I do get the logic. But if you ask me to write this out, not possible. I'm afraid it is not possible. I don't know about the Dijkstra's solution. What about the Dijkstra's? Is it even quicker? Time is slower, but memory is better. Let's see. I see. Well, I would not have been able to do that. Um, be what it is. Let's see, there's a hard one, right? Yeah. What this one? Outgoing. Yeah, I'm not reading this. Okay, well, very interesting stuff. Um, going to continue tomorrow, where I'm gonna be in Japan. Um, so expect shorter vlogs, easier questions, but进步是永远不可以停的。Peace.